Now, the good thing about integration is it is just reverse differentiation. So we already know how to do a lot of this stuff. There's not really going to be much new at all today. So let's have a look at, so if I said that y equals x cubed, then what is dy dx? 3x squared. Okay, so what we're going to do is think about reversing this process, right? How do I get from here back up to here? So if what we do is multiply the coefficient by the number at the top, how do I reverse that idea? Right, we're going to divide this by the number at the top here. So if I was going to go backwards, what I would say is I've got 3 and I'm going to divide it by 1 more than this, right? Because 1 more than this takes me back to the original. So whatever the coefficient is, you divide it by 1 more than the power. Then you just increase the power by 1, right? That's the theory. So 3 over 3 is 1, so we end up with x cubed again. Now, there is a slight issue with this, because what if I said that, let's say that f of x is 3x to the power of 4 minus 7x plus 10. All right, what is the derivative of that? What is the derivative of it? 12x cubed minus 7. Okay, so Josh is on the right track. If I want to derive this, sorry, if I want to integrate this, so if I want to go back again, let's do the same thing that we just did before. So we're going to divide. So we put this, we add the power, divide by the new power. Add a power, divide by the new power, right? See what's happening? So then if I do that, I get 3x to the power of 4 minus 7x. And as Josh has just pointed out, this 10 has disappeared, right? So when I integrate, when I reverse do this, I can't figure out what the constant was because it's not there for me to reverse engineer it. So what I'm going to do is I'm always going to write plus c. That is the bit that people will forget to do a lot. But plus c is just saying there's some constant there and I don't know what it is. So I'm just going to write in plus c. We'll show you how to work that out with more information. But whenever you integrate, always add plus c on the end because you don't know what constant used to be there. The constant might be 0. There might be nothing there at all. But either way, we're always going to write plus c. Does that make sense? All right, let's do a couple of examples of that. All right. So I'm going to say that f of x is 4x cubed minus 2 over x squared plus 4. All right. So if I want to work backwards and find my function, again, I add my power, divide by the new power. How do I rewrite this? Good. So remember this, so I'm just going to redo that. So I want to make sure that I don't have fractions. So again, I'm going to add 1 to the power, which makes it -1, divide by the new power. And then I've got over here, so 4x divide by the new power plus c. Never ever forget the plus c. Okay, add a power, divide by the new power. So what's this term? Just x to the power of 4. 4 divided 4 is 1. What happens here? Plus 2 over x, right? X to the -1 means it should be on the bottom. Plus 4x plus c. So this is my integrated function. All right, what I'm going to do now is show you some slightly different notation. So we haven't really used the sign of an integral before, so let's do that. So if I give you, I'm going to give you a function, x, oops, that's not what I wanted to do, 2x minus 1, 2x plus 3. All right, so if this is my function and I'm going to ask you to integrate it, this is my integral symbol. It's just a massive looking little s. Okay, it's a very tall, skinny sort of S sort of thing. It's not a big deal how you write it. But what we're going to do is write dx on the end because we are integrating this function with respect to x. So in the same way that we talked about differentiating with respect to x, later on we're going to differentiate with respect to y, depending on how we rotate some shapes later on in the topic. But for this one, we are differentiating with respect to x. So the first thing I do is I'm going to open up all of this. So what do I get? If I open up all of this, what do I get? 4x cubed. Because there's an x out the front. Plus 4x squared minus 3x. And I'm going to integrate that with respect to x, okay? That is just this all opened up. If you can't do that all in one step in your head, no worries. Write it out, do it in stages. So then what I want to do is integrate this. So add a power, divide by the new power. Add a power, divide by the new power. Add a power, divide by the new power. Am I done? What's wrong?
C.
Good. Plus C. Never forget to write this. There's some sort of constant. All right, so let's put that together. So let me just zoom out a little. All right, so then how do I simplify that? So I get x to the power of 4 plus 4/3 x cubed minus 3/2 x squared plus c. That is my integrated function. All right, so integration is not really that hard. It's just the reverse of differentiation. Just don't forget your plus c on the end. All right, let's do an example where we can find c, because if you get given more information, you can find out what c is. I know, it's shocking, isn't it? All right, so what if I had... So I'm going to tell you that the derivative is 6x to the power of 5 minus 18 all over x cubed. And I'm going to tell you that there is a point on the curve that is 1, 6. So the first thing I'm going to do is integrate my function. Oh, why did I draw that? I'm going to integrate my function. So, actually, first of all, let's just rewrite this so that we don't have a fraction. So what does this become? 6x to the power of 5. Shouldn't have done that. Minus 18 times x to the power of negative 3, right? Let's put this on both of those things. So what do I get? 6x squared minus 18x to the negative 3. All right, now let's integrate. So we add a power, divide by the new power. We add a power, divide by the new power, and plus c. So then what's this? 2x cubed, and this? 9x to the power of negative 2, right? These two negatives are going to cancel each other out. 18 divided 2 is 9 plus c. So what I'm going to do is, first of all, I'm just going to write it out better. Plus 9 over x squared plus c. Now, the thing about this is I know a particular point on this graph. I was given the point 1, 6. So I'm now going to put that in instead of x and y because this is the function. Oops, I did not mean to do that. This is f of x, right? This is y equals that. So I have a y coordinate and an x coordinate. So I'm going to put that in. Why did I do that? Jeez, why indeed? All right, so the y coordinate is 6, and then 2 times 1 cubed plus 9 over 1 squared plus c is going to be the function. So then I've got 6 equals 2 plus 9 plus c. This is 11, so minus 5 is c, which means I can now write my entire function over here. So the function is 2x cubed plus 9 over x squared minus 5. That is my final answer. See what I'm doing? So once you've integrated, you can be given a point and you can put that in to find the value of c. What if we combine this information with other topics though? What if we are, let's say, given information about the normal? So if I am given information, so I'm going to say that dy dx, so same notation as before, it's not the same notation, it's different notation, but it means the same thing. So dy dx is going to be 6x plus k. I'm not giving you enough information, but the gradient of the normal at 1, -3 is half. So now I want to find the equation of the curve. So if I'm given that information, I can work a lot of that out. All right, so if dy dx is that, what I'm going to do first is work out the function. So 6x, add a power, divide by the new power. Add a power, divide by the new power, right? Plus c. I don't know what's going on there. So this is going to be 3x squared plus kx plus c. Now, I was given some information over here that's going to be really helpful. So this is not great right now. But what I can do is say that I know that there is a point. So I'm going to change colors. I know that there's a point on the curve that is 1, 3. So I can now work out c, can't I? Well, sort of. I can find out more information anyway. So -3 is 3, 1 squared plus 1k plus c. So I can say that -3 plus 3, equals, nope, that's not what I'm trying to do at all. -3 equals 3 plus k plus c, which means that -6 equals k plus c. You with me so far? Okay, so I have some information about K and C, but I also have this information over here that I haven't used yet. So let's pick another color and do that. So I know that the gradient of the normal, so how do I find the gradient at a point?
Put the x value in.
Okay, so I've got the derivative already and I can put the x value in there, right? So what I know is that at the derivative, so the gradient of the normal is half. So what's the gradient of the tangent? Good. Tangent gradient is -2, so that's very good news. Okay, so I can work out, so when x is 1, the gradient is -2, right? So can't I go back into this thing up here and say that? The gradient is -2 when x is 1. So now I can work out the value of k. So I can say that -8 is k. So that's really helpful information. I can put that back in here now. So if I take this, let's change colors, and I put that over here, then I've got -6 equals -8 plus c, which means that c is 2. Right? Because we're going to add 8 to the -6. So that means I can now write my equation because I have this up here. I can now say that it is 3x squared plus, minus 8x, because that's what k is, plus c. Are you with me?